So today we're going to continue graphing linear equations in general, which is also called standard form. So last class we graphed linear equations that looked like y equals 2x plus 5 and y equals a third x minus 2. The way these two equations are written is called slope-intercept form. And notice that in this form, the y variable is written by itself on the left-hand side, and the rest of the expression is on the right-hand side. There are three different ways to write linear equations, and today we're going to look at general, which is also called standard form. So an example of this would be x minus y equals 5, 2x plus 3y equals 7, and so on. So in general form, all of the variables, in our case we're going to see x and y, with their coefficients, and remember the coefficients are the numbers that just sit right in front of the variable, they're multiplying the variable, are written on the left-hand side, and the constant is written on the right-hand side. And remember, a constant is a number that does not have a variable multiplying it. Alright, let's do an example. So we're going to set this up just like we did last class. We're going to first draw a t-table, and we're going to extend it, so it's a little bit bigger than a t, so that we can put our ordered pair in here. Now, we're going to start exactly the same as last time. We're going to use x equals 0 in here and try and find out what the y value is. Now, this isn't always going to be the case, but in this one it's pretty nice, and you'll get used to this with more practice. So if x equals 0, and our equation is x minus y equals 5, I'm going to substitute x equals 0 in wherever I see an x. And now what I have is negative y equals 5. Now, I don't want negative y. I want to know what y equals when x equals 0. So remember that it's like there's a negative 1 in front of there. It's kind of an invisible one. We don't write it because we don't need it there. It's implied that there's one of them. So what we're going to do is divide by negative 1. You might also already know that you can just divide by a negative 1 on both sides. And then negative 1 divided by negative 1 is just 1. So we end up with y equals, and 5 divided by negative 1 is negative 5. A positive divided by a negative is negative. So when x equals 0, y equals negative 5. And our point is 0, negative 5. And I'm going to graph that. So I start at my origin, I'm moving horizontally 0, and then I'm moving down 5. Alright, now the difference between slope-intercept form and standard or general form is that it really doesn't matter if I choose a value for x or a value for y, because we're going to have to manipulate the equation anyways. You could have chosen a value for y for slope-intercept form yesterday as well. It would have just been more work. So let's try choosing y equals 0, because that's really nice and easy. So the equation was x minus y equals 5, and wherever I see a y, I'm substituting a 0, and x minus 0 is just x, so x equals 5. So when x equals 5, y equals 0, our point is 5, 0. Remember, it goes in alphabetical order, x and then y. I'm starting at the origin, I'm moving 5 in the positive direction and 0 vertically, and I'm going to label it. Alright, now we have to choose one more. It doesn't matter if you choose a value for x or y here. We're going to see next in the next one, sometimes you have to make a smart decision. In this one, it's very nice and simple. So I don't know, let's just choose y equals negative 7. And remember, the equation is x minus y equals 5. So wherever I see the y, I'm going to substitute negative 7. Now, these brackets might be really important for you, because this subtraction sign stays there, and the entire value y equals negative 7 has to be substituted in here. If you forget that negative, then you would end up with the wrong answer. So here we have x and a negative and a negative. Remember, you're changing directions twice. So you would have a positive 7 equals 5. And then I'm trying to solve for x, so I must subtract 7 from both sides, get it by itself. X equals 5 minus 7 is negative 2. So when y equals negative 7, x equals negative 2. So my ordered pair is negative 2, comma, negative 7. And I'm going to go and graph that. So I start at my origin and I move back 2, and then I move down 7. And I can draw my straight line. If you have a ruler, it might help you a bit. If you don't have a ruler, just try and make the straightest line you possibly can. Now, on our graph, we always need arrowheads. We always need the labeling of the points. And then finally, we need to actually label the graph by putting the equation of our line in. And I've got everything labeled. All right, let's do another one. So same thing, I'm going to set up my t-tables, my extended t-tables, and I'll put my ordered pair in there so we can graph it. It's a little bit easier. You don't have to have the ordered pair there if you don't want. Again, I'm going to start by just using x equals 0. So this isn't always going to give you a nice good point. So remember, a good point has no decimals or no fractions in it. It needs to be an integer, so a positive or a negative whole number. But in our case here, it does work nicely. Okay, so wherever I see an x, I'm substituting the 0. And 2 multiplied by 0 is 0. And I get y equals 4. So when x equals 0, y equals 4. And my ordered pair is 0, 4. And if I graph that, I go to my origin, I'm moving nothing, 0 horizontally, and then I'm moving up 4 vertically. And I'm going to label that. Alright, now I'm going to choose y equals 0 because that was nice and easy last time. Now again, remember, this might not work. You might not get a nice integer out of it. And in that case, you'd have to choose a different number. Our equation is 2x plus y equals 4. I'm substituting y equals 0, so wherever I see that y, I'm going to put a 0 in. And then 2x plus 0 is just 2x. And remember, I'm trying to solve for x, so I must divide both sides by 2. 2 divided by 2 is 1, so I get x equals, and 4 divided by 2 is 2. So when y equals 0, x equals 2. My ordered pair is going to be x is 2, y is 0, and I'm going to graph that again. So I go up to my origin, and it's telling me to move horizontally 2 and vertically 0. And I'm going to label it. Okay, now we have to choose one more point. We want to have 3, just in case we made a mistake. This will help us. Now, you actually have to have a little bit of a thought process behind this. For our next point, what I want you to notice with the equation, it's 2x plus y equals 4. So when I chose a value for y, notice at the end I had to divide by 2. And that's because I'm going to have this 2 multiplied by the x. I'm going to have to divide by 2 if I choose a value for y. So if I was going to choose a value for y, because my constant is 4 and it's an even number, I would have to choose an even number for y. Otherwise, I would end up with a decimal or a fraction. If you're not sure, you could try a few of those. Try a few different numbers and see what happens. Notice that when I chose a value for x, my y value, the coefficient here is actually 1. So because I'm just dividing by 1, it doesn't actually matter what value for x I would choose. So I don't know, it's easier for us if we choose a value for x. You don't have to. You can choose whatever number you want. Obviously there's some restrictions on that. I'm just going to choose x equals negative 3. So if x equals negative 3, then I get 2 multiplied by negative 3 plus y equals 4. So I end up with negative 6 plus y equals 4. And then because I'm trying to solve for y, I'm going to add 6 to both sides. And I get y equals 10. So when x equals negative 3, y equals 10. My ordered pair is negative 3, 10. And on my graph, I start at my origin, and I'm going to count over negative 3 and up 10. And I'm going to label it, and then I'm going to put my line through it. I'm going to put my arrowheads on my line, and then I'm going to put the equation on. For a complete correct answer, you need to have the arrowheads, you need to have the labeling of the points, and you need to have labeling of the graph, and it has to be on the graph. And we're done.